You've seen it countless times. You step out of the shower, grab a fresh towel, and as soon as it touches your wet skin, boom, it instantly looks darker. A profound transformation, right before your eyes. But why? Is it some fleeting magic, or perhaps a deep secret embedded in the very fabric of our reality? A secret rooted in the fundamental laws of physics that govern our universe. This isn't just about towels. Think about a dry pebble on a beach, dull and unremarkable. Dip it in water, and suddenly its vibrant patterns and deep hues burst forth. Or consider the pavement after a rain shower. The wet patches appear dramatically darker than the dry areas. This ubiquitous phenomenon, so common we often overlook it, begs a deeper question. What unseen forces are at play here? For generations, we've pondered this. Many intuitively assume it's the water itself reflecting light differently, or perhaps a chemical reaction with the fabric's dyes. Some might even suggest the water is somehow saturating the color. But these explanations, while seemingly logical, don't quite capture the elegant scientific truth. The real answer lies in a beautiful, intricate dance between light, water, and the microscopic architecture of the material itself. Let's zoom in, far beyond what the naked eye can see, into the very structure of a dry towel. It's not a solid surface, but a marvel of engineering. A fluffy, interwoven labyrinth of countless tiny fibers. These fibers, often made of cotton or microfiber, create a vast network of microscopic air pockets and tiny imperfections. When ambient light strikes this dry, porous surface, it doesn't just hit and reflect. Instead, it scatters. It bounces off the fiber surfaces, reflects within the air gaps, and generally gets dispersed in every conceivable direction. This widespread scattering of light is why dry towels often appear lighter, softer in color, sometimes even a bit muted or faded. Think of it like a dense fog, effectively scattering and diffusing all incoming light. Now, introduce water. As those water molecules penetrate the towel, they don't just dampen it, they perform a microscopic invasion. Capillary action draws the water into those myriad tiny air pockets and crevices. These air-filled voids, once responsible for the chaotic scattering of light, are now completely replaced by water. This is the crucial turning point. Water is significantly denser than air, and it possesses a very different refractive index. Its ability to bend light. With the air pockets filled with water, the path of light dramatically changes. Instead of haphazardly scattering off air fiber interfaces, light now travels more directly through the water-filled gaps, encountering fewer reflective surfaces. This significantly reduces diffuse reflection, the scattering of light in many directions. When light enters the wet fibers and the water, it undergoes a process called refraction, bending as it passes from one medium to another. More importantly, the water facilitates a more direct path for light to reach the fabric's dyes. As light interacts more directly with the dye molecules, more of its wavelengths are absorbed by the fabric, and less is reflected back to your eyes. The light that does get reflected is often concentrated in a narrower angle. The combined effect is profound: reduced scattering, increased absorption, and more focused reflection. What we perceive is not the towel magically changing its intrinsic color, but rather its true, richer, and often deeper shade being revealed. The water acts like a transparent medium, removing the veil of scattered light that previously made the dry towel appear lighter. It's an optical illusion, a trick of light and substance, where the wetness intensifies the perception of color saturation. This is why a simple splash transforms the mundane into a moment of scientific wonder. This principle extends far beyond just towels. From the wet ground after a summer rain to the vibrant colors of gemstones revealed when polished with oil, the physics remains the same. Any porous material with microscopic air gaps will exhibit this phenomenon when those gaps are filled with a liquid with a different refractive index. It's a testament to the elegant, interconnected nature of the physical world, where seemingly simple observations hide sophisticated scientific explanations. So, the next time you witness your towel transform from pale to profound, or see the pavement darken after a downpour, take a moment. You're not just seeing something get wet. You're witnessing a stunning display of light, optics, and material science in action. It's a reminder that even in the most ordinary moments, our world is brimming with extraordinary scientific marvels, waiting for curious minds to uncover them. What other everyday mysteries are waiting to be explained?